If you have ever cracked open a Cold War military history book, you have been force-fed the same legend over and over again. A 10-to-1 kill ratio in favor of the F-86 Sabre over the MiG-15. But I need to be straight with you. As someone who has spent years buried in declassified technical files, that number is a textbook case of Cold War propaganda. The truth above the transonic skies of MiG Alley was not a one-sided joyride. It was brutal. It was grinding. And it became the bloodiest physics laboratory in the history of aerial warfare. Welcome! For the next 25 minutes, we are not here to repeat comfortable myths. I am going to take you deep inside the cockpit, tear apart the engineering blueprints of the two most important swept-wing jet fighters ever built, and show you exactly why a raw, violent Soviet aerodynamic platform ran into serious trouble against America's precision, human-centered design philosophy. You will understand clearly why this matchup was never really about which weapon destroyed more of the other. It was about how this single air war completely rewrote the doctrine of aerial combat for the 21st century. The clearest proof of that, a thinking framework called the OODA loop, born directly from the blood and chaos of MiG Alley. The classified files are open. Let us start decoding the most technically brutal chapters of aviation history. Summer, 1944. As the West was stunned. The appearance of Germany's Mi-262 jet fighters had turned the finest propeller-driven aircraft of the Allied forces into slow, obsolete toys. But speed always demands a brutal price. As aircraft approached the speed of sound, air molecules could no longer slide smoothly over the wings. They piled up into shock waves, creating what engineers call compressibility drag, a physical phenomenon violent enough to rip an airframe apart mid-flight. America's XP-86 program was completely deadlocked. With its original straight-wing design, North America's aircraft could not punch through the 600-mile-per-hour barrier, and the dream of American dominance in transonic skies was about to die on the drawing board. Then a miracle appeared. When the Third Reich collapsed, both the United States and the Soviet Union launched an unprecedented scramble for war trophies, and the greatest prize was not gold. It was the top-secret swept-wing aerodynamic data seized from German research laboratories. Everything changed overnight. American engineers boldly scrapped their old blueprints and applied a 35-degree wing sweep, combined with automatic leading-edge slots copied directly from the Mi-262 design. That combination allowed the Sabre to slash through shock waves, look at high speed while still maintaining enough lift to avoid dropping out of the sky like a stone during landing. A new chapter was written. In October 1947, that the XP-86 prototype took flight, and not long after, it proudly became the first Western fighter to break the sound barrier in a dive. At the very same moment, the Russians were wide awake. They immediately combined captured German aerodynamic data from the Focke-Wulf Ta-183 prototype to build a completely new airframe, but slammed into a fatal problem. Soviet industry had no jet engine powerful enough to match it. A ridiculously costly geopolitical blunder saved them. As someone who studies this history closely, I still find it hard to believe every time I read it. But the British government of that era generously sold Moscow its most advanced Rolls-Royce Nene jet, the engines. The Soviets immediately reverse-engineered them into the Klimov Valvine K-1 power plant, generating a massive thrust of nearly 6,000 pounds. The race was officially on. In late December 1947, less than 3 months after the Sabre's first flight, the MiG-15, carrying a British heart inside a Soviet body, roared into the sky and created the perfect counterweight that would hang over every American pilot's worst nightmares. Same swept-wing aerodynamic foundation. Two superpowers solving two completely opposite strategic problems. Forget the dry military terminology for a moment. Think of this confrontation exactly like a death race between a Soviet muscle car and an American precision sports car. The MiG-15 was that muscle car. Lean and savage, with a takeoff weight of just over 11,800 pounds. It was packed with a climb-off VK1 engine producing nearly 6,000 pounds of thrust. That thrust-to-weight ratio gave it the ability to tear straight up into the sky, all the way to a ceiling of 50,000 feet. Its design objective was absolutely ruthless. It was built with one purpose: carry a massive hammer into the sky. One 37mm cannon and two 23mm guns. Its only job was to smash American B-29 strategic bombers into scrap metal. But swinging a hammer is always slow. The destructive power was terrifying. A single round hitting the Sabre's airframe could tear it apart. Yet the low muzzle velocity, arcing ballistic trajectory, and the outdated ASP-3N optical gun sight made actually hitting a nimble, slashing fighter an absolute nightmare for communist pilots. Across the front lines, the F-86 Sabre was something entirely different. Heavy, at over 13,700 pounds at takeoff, and a weaker climber. The Sabre looked outmatched on paper if you only read the raw performance numbers. But it was built to grip the sharpest corners. When I studied the declassified technical files, I was genuinely impressed by how far ahead of its time America was on ergonomics. The Sabre's fully hydraulic flight control system moved with the effortless precision of power steering in a modern automobile. A pilot could snap the jet into a rolling reversal at high speed without the aerodynamic forces crushing the strength out of his arms. Instead of a hammer, the F-86 carried on precision sewing machine. 6 M3 machine guns, each firing 1,200 rounds per minute, could throw a wall of steel through the exact space a target was about to fly into. More dangerous than the guns was the aircraft's brain. Equipped with the AN/A PG-30 radar ranging gun sight, the Sabre's ballistic computer continuously measured distance and automatically calculated the lead firing solution out to 2,000 yards, roughly 1,800 meters. American pilots simply placed the enemy in the reticle and pulled the trigger. No guesswork. No estimation by eye. That was a classic asymmetry. Raw destructive force on one side. Intelligent, concentrated firepower on the other. And the skies over Korea were about to render judgment on which philosophy would survive. But America's precision machine had an Achilles heel. While it dominated below 30,000 feet, the Sabre's original design ran out of breath in the thin air above that altitude, where the MiG-15 could use its thrust advantage to slice tight corners, pull vertical climbs, and reverse the entire tactical situation. The U.S. Air Force needed an urgent solution. And so the engineers at North American performed one of the most audacious, borderline insane aerodynamic surgeries ever carried out at the front lines of a war, giving birth to an upgrade that changed the rules of every engagement. The 6-3 wing. A life-or-death decision was made. They completely removed the automatic leading-edge slats, the very component that had been borrowed from German engineering to keep airflow stable and prevent the aircraft from falling like a brick at low speed. In their place, a new geometric profile was cut. The wing root was widened by 6 inches, the wingtip extended by 3 inches to increase total surface area, and a wing fence, a thin aerodynamic boundary strip, was bonded along the upper surface of the wing to redirect the airflow. A small piece of sheet metal. A seismic shift in performance. That fence controlled the chaotic boundary layer, significantly delayed the onset of buffeting and gave Sabre pilots the confidence to pull extreme G-loads, outturn the MiG-15, dig and stay locked onto a target even at high altitude. But the price was always paid in blood. I felt a genuine chill reading the accident reports from this period. Removing the slats drove the stall speed up from 128 miles per hour all the way to 144, bringing with it vicious uncommanded rolls and yaw snap maneuvers if the aircraft ever bled too much speed. Every runway became a waiting executioner. Landing approaches turned into nightmares for inexperienced pilots still learning the jet. But that was the merciless trade the Americans were willing to accept to transform the Sabre into the supreme apex predator of close-quarters air combat. Stop for 1 second. Put yourself in that cockpit. The year is 1950. You lift off tomorrow morning. Do you strap into the raw Soviet muscle car, the MiG-15, with its 37mm hammer that tears apart everything it touches? Or do you trust your life to the American precision sports car, the F-86 Sabre, with its radar gun sight, its hydraulic controls, and its technology-first cockpit? Drop your answer in the comments right now. I read every one of them. Now, set aside the blueprints. It is time to look straight at the kill numbers and the blood-soaked truth from the front lines. Do not mistake this for a story about individual pilots. This was an industrial collision on a global scale. More than 11,000 MiG-15s poured off Soviet production, lines to face 9,860 Sabres fielded by the West. American precision always carried a staggering price tag. The factory unit cost of a single F-86A in 1949 was $178,408. In today's purchasing power, that is millions of dollars for one airframe. But the most devastating cost was in operations. As someone who analyzes maintenance metrics professionally, I can tell you that the early jet era was a genuine logistical nightmare. To repair a single jammed control cable, American technicians sometimes had to physically separate the Sabre into two sections, disconnecting the entire tail assembly just to reach the fault inside. Every runway was a scythe waiting to swing. The sudden transition to high-speed jet operations drove the F-86's Class A mishap rate in 1950 to a staggering 134.46 accidents per 100,000 flight hours. Across the jet's entire service life, 1,422 Sabres were destroyed, and 573 American pilots lost their lives not to enemy guns, but to mechanical failures and human error. A devastating blood tax for opening the door to the supersonic age. The skies over Korea. December 17th, 1950. The air combat history changed forever. Knowing that Soviet pilots routinely prowled at 50,000 feet, safely above the Sabre's practical reach, Lieutenant Colonel Bruce Hinton of the 336th Fighter Squadron laid out a tactical trap of extraordinary cunning. He led a four-ship Sabre formation, flying at a deliberately slow 300 knots, in a loose formation designed to look exactly like a flight of aging, weak F-80 straight-wing jets on a routine patrol. The bait was taken. 4 MiGs dove for what they thought was easy prey. But the moment they leveled off to line up their shots, Hinton slammed the throttle to the stop, snapped the Sabre into a diving, reversal, and locked onto the enemy's tail. At a firing distance of just 600 feet, 6 M3 guns tore apart the MiG's wing root and turned it into a falling fireball. The F-86 Sabre scored its first confirmed kill, opening the curtain on 3 years of grinding, brutal aerial attrition. The Sabre could shoot down MiGs, But could it protect the strategic bombers? The answer was a humiliating failure. On Black Thursday, April the 12th, 1951, 39 B-29 superfortresses, shielded by 54 F-84s and 24 F-86s, pressed toward bridge targets along the Yalu River. 3 waves of MiG-15s sliced through the fighter screen like thrown spears, using their dive speed to punch through American formations, unleashing 37mm cannon fire that destroyed 3 B-29s outright and crippled many more. The catastrophe repeated itself. In October 1951, even on Black Tuesday, despite every desperate effort by Sabre pilots, the MiGs strangled the bomber formation once again, forcing U.S. Air Force commanders to issue their most painful order of the entire war. All daylight B-29 strategic bombing missions were permanently suspended. From a strategic analysis standpoint, I have to be honest about this. The MiG-15 may have been outmatched in a turning dogfight, but it accomplished 100% of the objective its Soviet designers had assigned it. It was an absolute strategic bomber killer, and it proved it with total, undeniable effectiveness. Dominance always breeds the most dangerous disease in combat aviation: lethal arrogance. When the experienced Soviet veterans rotated home and were replaced by Chinese and North Korean novices with fewer than 50 jet hours each, Sabre pilots began racking up kills with brutal efficiency, and quickly fell into a psychological trap the veterans called MiG madness. They broke formation. They chased individual scores. They threw away the mutual support that kept them alive. The lesson arrived in blood. On February 10th, 1952, Major George Davis, the leading American ace of the war with 14 aerial victories, overconfidently led his flight straight into a formation of dozens of Chinese MiGs. He managed to destroy 2 before Chinese pilot Zhang Jihui planted a 37mm round into his Sabre. Davis lost control and drove into the hillside below. One rule no fighter pilot can ever afford to forget: never underestimate the destructive power of a well-aimed hammer. The Sabre's legend was not buried in Korea. It kept being written in blood across South Asia. In the 1965 Indo-Pakistani War, Pakistan Air Force F-86s tore into the Indian Air Force with Sidewinder missiles, and the squadron leader cemented his legacy as one of the most celebrated fighter pilots in aviation history. But on those same battlefields, the Sabre also tasted bitterness. Nimble Indian fallen gnats, hunting at low altitude, earned the permanent nickname the Sabre Slayers. The most tragic chapter came in 1971 in East Pakistan. Completely cut off, a single squadron, 14 aging F-86 Sabres, was surrounded by nearly 200 Indian aircraft pressing in from every direction. Outnumbered more than 10 to 1, Pakistani pilot Flight Lieutenant Maqsood Amir did something that defies logic. He shot down a modern supersonic MiG-21 with his decades-old Sabre. When the runway itself was finally destroyed and no departure was possible, the remaining Pakistani pilots made their final decision with absolute dignity. They personally cut the power lines and destroyed 11 of their own Sabres by hand, refusing to let a single aircraft fall into enemy hands. The chapter closed in fire. So who actually won? Throughout the Cold War, the Western propaganda machine repeated the 10-to-1 kill ratio like a sacred verse. That number is nonsense. Modern declassified analysis has proven it as the predictable product of overclaiming. The gun camera footage records a flash of rounds hitting the target. It does not prove the aircraft actually reached the ground. Damaged MiGs that limped back across the Yalu were counted as kills by the pilots who hit them. The real, honest, verified numbers are far more sobering. The true overall kill ratio sits at approximately 5.8 to 1, roughly 78 to 92 Sabres, lost in air-to-air combat, in exchange for approximately 566 MiGs destroyed. When F-86s faced Chinese or North Korean rookies, they dominated at roughly 8 to 1. But when they met the battle-hardened Soviet aces of the 64th Fighter Aviation Corps, veterans of a World War II, the ratio collapsed to somewhere between 1.2 and 1.5 to 1. A knife fight, equal on both sides. The Sabre won the fighter versus fighter duel through ergonomics. The MiG-15 used raw muscle power to strangle America's strategic bombing campaign. Placing these two machines on the same scale reveals a permanent truth. No aircraft is invincible. Everything is decided by the human being in the cockpit, and, by the doctrine of war, they are forced to carry on their shoulders. So, what actually made the difference? If you feed the raw physical specifications of both aircraft into a supercomputer and let the mathematics decide, MiG-15 wins on paper. Superior thrust-to-weight ratio, thousands of feet higher service ceiling, stronger acceleration, tighter turning radius across multiple speed bands. By pure theory, the MiG should have owned every cubic mile of that sky. But as I worked through the declassified operational reports, I found a single truth that rewrote all of modern military thinking. The F-86 bikes. Sabre's dominance in turning engagements did not come from raw mechanical power. It came from ergonomics, from the seamless connection between the machine and the human nervous system. Colonel John Boyd, brilliant military theorist, former Sabre pilot, and the most influential fighter tactician of the 20th century, called it an anomaly. And from that blood-soaked anomaly, he built the greatest doctrine in the history of modern air combat, the OODA loop. Observe, orient, decide, act. Look at exactly how the Sabre optimized every single step. In the observe phase, the Sabre's bubble canopy, a seamless, unbroken arc of plexiglass, eliminated blind spots completely. While Soviet pilots were partially blocked by their canopy framing, American pilots spotted the enemy first, every time, giving the brain those precious extra seconds to orient and build a spatial picture. Then came the decide and act phases. At transonic speeds, aerodynamic pressure on control surfaces loads up to several tons of force. MiG-15 pilots had to wrestle a mechanical cable system with the raw strength of their hands and arms. Reaction slowed, energy drained within minutes. The F-86 carried a fully hydraulic flight control system. A light, fluid flick of the wrist was all it took to a snap from a climbing turn to an inverted reversal at any speed. That is the cruelty of the OODA loop. I believe personally that America's ultimate weapon in MiG Alley was not the M3 machine gun. It was the ability to slip inside the enemy's cognitive cycle. By thinking and acting one beat faster, the Sabre drove its opponents into information overload, confusion, and total paralysis. The aircraft did not fight. The human being was the weapon, and the machine that served its human better won the war. More than a weapon, the Sabre became a geopolitical laboratory. In the fall of 1958, during the Taiwan Strait crisis, the United States secretly armed F-86 fighters with a weapon that permanently altered the history of aerial combat: the AIM-9 Sidewinder heat-seeking missile. For the first time, MiGs cruising at their comfortable high-altitude safety margin were blown apart from distances far beyond visual range by missiles chasing the heat signature of their own exhaust pipes. The Sabre had completed its historical mission. It closed the era of close-range gun dogfighting, and, with its own hands, it opened the brutal new chapter of beyond visual range missile warfare. The Sabre and the Faggot taught the world what jet combat meant. But MiG Alley was only the innocent prologue to what was about to hit the world a decade later, when the guns were stripped away entirely, when radar and missiles became the only arbiters of life and death. The skies over Vietnam witnessed the collision of the two most insane design philosophies of the 20th century. On one side, the massive, lumbering F-4 Phantom, the Pentagon's bet on pure brute force missile technology. On the other, the small, lightning-fast MiG-21, made to carrying the cold precision of the Soviet Union. How does the OODA loop survive when you cannot even see the aircraft that just fired at you? Do not go anywhere. Click the video on your screen right now and decode the next blood-soaked duel. F-4 Phantom versus MiG-21. The supersonic sky is waiting. Click it.